missing. In the last lecture, I will check if there are typos. Yes, because this to be really an F of Fisher, I should have divided this by, yes, because the two samples I read here, they have different dimensions. No, probably wanted to say that the dimensions are also the same. No, but I will tell you the last lecture. I will tell you what you have to modify. You know, yes, here I want to change. I want to say that the dimensions are equal. Then, if the dimensions are equal, then you get exactly this result because you can simplify the denominator. Otherwise, you cannot simplify them, and so yeah. However, it's an F of Fisher, okay? But I need to modify here to say that the dimension of the samples is also the same. Yes. Do you have another question?
Yes, about exercise exam G, exercise number 5, letter B.
Wait. Exercise G. No, exam G. G and letter B.
Of number 5.
Ah, number 5. This one.
Yeah, because in general, when we have the confidence interval, we have like the sigma square, but here we have just sigma. So, like, I was wondering if we
we did it in the exercise equal to this one. First build for sigma square.
Okay, then we do the square root.
Yes, then the square root. Yes, we did the same in the exercises. Yes.
No, just a question to understand if I understood well. Okay.
Yes, no problem.
Thank you.
This one was the last. Okay. No, very good. Welcome. Then I repeat, in the last lecture, I think we will do 3 hours, and in these 3 hours you can ask me again whatever you want about these exercises, and maybe if you have few questions, I will solve the exercise you asked me to solve in that lecture. And if you have no question, I can take randomly some exercising among them and I can solve it. Okay, other question, guys? Do you have other questions? Otherwise, you have time later. Good morning, guys. Yes, maybe we wait 3 minutes and then we start with the lecture. Okay, the last 3 minutes. So, okay. Now let me start to record. Otherwise, I forget to record. So I close this one. And today we need to continue by doing exercises on confidence intervals and hypothesis testing. Okay, now we wait. Okay, I'm simply talking, but I'm not explaining. Okay, I'm not explaining. I want you to remember only what you are going to do. So today we are going to finish this presentation containing confidence interval and hypothesis testing. Maybe we'll take another look to the tables. Okay, another quick look to the tables. Then tomorrow, I think we have 6 hours. Tomorrow we will do the last presentation concerning the simple linear regression model, and we will do also the last and also the exercises. So we will spend about 3-4 hours to review, to study the simple linear regression model, and the last 2 hours to do exercises. And then we have another lecture, the last lecture of 3 hours, and in the last lecture of 3 hours you will ask me if you try to do the exercises and you have troubles, you can ask me and I will do the exercise with you. I will not do the most intensive exercises with calculation. I mean, I will explain them because I have no solution. So the one which requires simply calculation with your pocket calculator are the simplest one, but they need to make computation, and in this case I will explain what you have to do. But for other exercises like the one on probabilities, random variables, okay, we will do them together if you have question, or I'll do first what you want, okay? So if there is something not clear for you, you want I discuss it again, I'll explain it again. Okay, That being said, start to think, guys, to a possible date for the test of the crash course. In Forlì, I tell you that I already fixed it, the 22 of December in the morning. If you like, we can do 22 of December in the afternoon. But it's not only suggestion. If you have another what can you say? If you have another date you prefer between the 20, 21, I don't know, 22. I mean, so when you are free from your courses, if you prefer when you are free from your courses before Christmas, you can select the date. But you decide, guys. I think you that are attending the this course have more rights than other students not attending it. So for me, it's good if you decide. For example, now you are only 16. It's better if you decide. I don't care about the other. Okay, I care more of you. Okay, of people attending the crash course. Okay. And so you can decide it. And another observation, since you are a very few students today at least, and also in the last lecture, well, the crash course, as I told you, so last minute, and then I do not want people to come the day of the exam trying to cheat, because if I get someone to cheat, this student will get automatically minus 10 points. Minus 10 points means that I will tell to the professors of the course of applied econometrics that you cheated and you got minus 10 points. So for example, if you get 25 on average on applied econometrics, minus 10 gives you 15, so you do not pass the exam. If you got 30, but it's hard that you got 30 if you try to cheat with me. If you got 30 minus 10, you get 20. But obviously, more likely, if you try to cheat, you are not a guy able to take 30 in the exam of applied econometrics, but someone who wants to cheat in both exams. Okay, so cheating is really forbidden. And as I told you, I think I told you already that during this pandemic year, I got several students who can turn off your microphone. Yes. Can you? Thank you. I caught several students trying to cheat, but I advised them very early, several times, of the consequences. And since in those exams I am the chief, here I'm not the chief. You have only the crash course. The chief, I mean, is a professor of a real course of applied econometrics. So here I'm simply talking with them, but I left them to decide what they do. I gave them suggestion. Here, when I am the chief, I think I told you at least for student in Forlì, so I don't know if I told you these things already also to you. Well, last 2 years, yes, last years, I got I got several students trying to cheat, even if I advised them from the beginning of the consequences of cheating, because I'm not kidding on cheating, because cheating in this way is really, come on, is really something, is like something really bad to cheat. It's like if you want to cheat, stop to study, go directly to do the politician. But so here we are not politician here. We are your students. You have to work. And so, guys, and when a student cheat, every student I got to cheat in my exam, they obviously failed the exam, but they had to wait other 12 full months to be able to take again my exam. And after that, when they take the exam, they can take it only as an oral exam with all the theorems, with all the proof, etc., etc., etc. So I advise them so many times, but there are people that believe to be smarter, but unfortunately for them, I can recognize if you cheated even when I check the exam. When I check the exam, I understand if you cheated. So don't cheat it. Okay, some student uses the computer, online solvers, and other things, but I find them okay? And I can only try to make you immediate and oral to understand if I think you cheated, but I'm almost sure that you cheated, but I need to be sure 100% that you cheated. Well, I ask you a question after the exam. I ask you a question, and from that question I understand that you cheated or not. So guys, don't cheat. It's better to avoid to take the exam than taking the exam and cheating, okay? Cheating is really something disgusting, because cheating today is not as when I was young. I mean, you have a doubt, you have ask a question to your friend tells you 2 words, and if you studied from the 2 words your friend gives you, you say, oh, okay, thank you. But this is not real cheating. But today, take a picture of an exam made up by another student completely with 0 knowledge of the subject. This is very bad. Okay, it's different. 20 years ago, 1 word. But today, instead, people can copy directly everything, can use also the PC online, I mean, can find also websites that are able to do the exercises. I'm talking especially of mathematics, because I'm teaching mathematics. But, okay, so that being said, guys, so I tell it not for you we are attending, but for several people, because I'm sure that several people would like to take the exam by cheating, because I'm pretty sure that almost very few students will pay attention to the recording uploaded it. They do not attend they now. Do you think that they will have time in the future to see the recording? Maybe a student who lost 1 recording can do it. A student that lost 2 recordings, but people who are never here, do you think that they will find the time to well, they don't care at all. They will come directly to the exam with the purpose of cheating. So guys, I'm recording what I'm saying, because I want that, but obviously if they do not even listen to the recording, they will come to the exam to make us to lose, to waste time. Okay, but we will talk of the exam also in the next lecture. Okay, now we are only 18. This is a very bad thing, and very bad thing, but okay, now we start. We start, guys. Guys, do you remember which was the last exercise we did together? Was the exercise about Michael Jordan? Do you remember it, guys? Remember, I remember that we did exercises, some exercises on confidence interval. I'm not sure, but I think we did together the exercise on Michael Jordan's. Do you remember? Was this one?
Yes, it was number 4.
Yes.
Yes, so we did. So we need to go to do 5 now. Thank you, guys. Let me see. Maybe you are answering me. You have. I have a question. Yes, ask me, Valentina. You can ask the question. We will talk, okay, guys, again about the exam. We can talk about the exam also. We have other lecture, so we have time. Then you can make me other question. Let me see. No, you can ask me later. Now we start, Valentina. Yes, ask me later about the exercise during the break. Now, during the break, you can ask me the question. Now on 9 and 14 we need to start, but later you can ask me at the end of during the break, you can ask me question. Yes, thank you, Valentina. So guys, now we did this one. So a broker asserts that the monthly expected return, so the monthly average return of a portfolio is 1%. with the standard deviation of 2%. These are statements made up by the broker. By observing the last 5-year performances of this portfolio, you compute an average monthly return of 0.8% and the sample standard unbiased and the sample unbiased standard deviation of 2.5%. So at a significance level or at a tail probability level of 5%, is accurate the statement of the broker? In particular, guys, what I'm talking here, to be more precise, I want to talk about the statement concerning the expectation of the portfolio. I didn't consider the standard deviation, so here I was explicitly talking about mu. I will be more clear in the exercise. Okay, so see here, I'm here and tell you at a significance level of 5%, is it accurate the statement of the broker? And for statement I mean that the broker asserts that the monthly expected return of a portfolio that he manages is 1%. Okay, however, we observed the last 5-year performances of this portfolio. That is, we computed the monthly returns over a period of 5 years. So how many observations do we have? In a year we have 12 months, so 12 monthly returns. Then times 5, 60 monthly returns. So this means that in order to check if the statement of the broker concerning the expected return to be equal to 1% can be considered true at a given significance level, we selected what? A sample of 60 monthly return. Then we computed the average of this monthly return and we get an average monthly return of 0.8%. And we got an estimate of the unbiased standard deviation, which is S hat of 2.5%. So 0.8% is small x bar and S hat equal to 2.5%. And the dimension of the sample is 60. So 0.8 asks us if the statement of the broker, that is the statement that the expected return on a monthly basis of the portfolio is 1%, must be tested at the significance level or tail probability level of 5%. We are required also to compute the p-value of the test at least here guys something has been cut, at least approximatively. Okay, at least approximatively we need also to compute the value of the test. So which is the hypothesis testing that we need to check? Under the null, that the statement of the broker is true, correct. So mu equal to mu0, so mu equal to 1%. Okay, statement of the broker is correct. That under the alternative, you have the assumption, the hypothesis that the statement of the broker is not correct. So the expected monthly return different from mu0, different from 1%. As I told you here, you see, I reported the observation, which are 60, the observed or estimated average return, which is 0.8%, and the estimated unbiased and we reported an unbiased estimate of the standard deviation of the monthly return, which is 2.5%. Then we are asked to test this hypothesis at a tail probability level of 5%. Since the alternative is bidirectional, you have to find two critical values. So we need to divide alpha in 2. So divide alpha by 2, you get 2.5%. Now, to understand which is the statistic test that we need to use, we need to think to our assumption. Are the monthly returns normally distributed? Is the population of the monthly return normally distributed? No, we have no assumption about the distribution of the monthly return. However, we are in the case in which n the dimension of the sample is 60. So since the dimension of the sample is 60, and since the variance of the population, that is sigma square, the variance of the monthly return is not known, what do we need to use? If you look at the tables, let me take the tables again, we are in case B. We are in case, no, we are in case B. The reference distribution is the student's t with n-1 degrees, is n-1. We are talking about a huge sample, so is the theta. So we can build an asymptotic test. I show now the case should be case D. Now let me show you what I'm talking about, because I told you that at a certain point you must know all the cases. So if you look, yes, we are in case D because we do not know the distribution of x. Sigma square is unknown, but n is huge. So as I told you, we need to build an asymptotic confidence interval, and this is the statistic test to use and its distribution under the null. So if you go back, in fact, you see that I take x bar, capital X bar, minus mu0 s hat times square root of n follows, I simply copy this result, guys, this one, follows asymptotically under the null assumption a standard normal distribution. Furthermore, I mean, here I explain, since n is huge, okay, n is huge, the variance is not known, so you have to use this formula, because if the variance was known, you had to use formula C. But you see, the difference between case C and case D is the fact that sigma square here is known and here is not known, so you have to work with this one. Okay, so compute the observed value of the statistic test. Theta ops is the observed value of the statistic test. What you have to do? You have to insert into capital X bar, small x bar, so the estimated sample mean, minus mu0. Mu0 is 1% divided the standard deviation s hat, but I mean the estimate of the standard deviation, which is 2.5%, times square root of n. N is 60, the dimension of the sample. So if you do the computation, you get this result. This is the observed value. As you must know now very well, what you have to do? You have to compare the observed value of the test with what? With the critical values. Where can you find the critical values? Well, under the null, the distribution of the statistic test is a standard normal. So we need to find the value theta alpha over 2. That is theta of 2.5%. So I take again the table to review with you the use of the table again. So we need to take the table. In particular, we need to work with the table of the standard normal, this one. And we want to find theta of 2.5%. That is, we want to find the value of theta such that the amount of probability on its right side, that is the white area, is 2.5%. But remember that the table of the theta are built in such a way that you can observe only the probability on the left side, that is the green one. But remember that the values small theta such that the amount of probability here, this one, is 2.5%, is the same value such that the amount of probability here is 1 minus 2.5%. So is 0.975. So again, look at 0. We use this, okay, we got it several times because, guys, these are the most used critical level, confidence level. So 1.9 or tail probability 1.9. If you go above 6, 1.96. So the two critical values are plus and minus 1.96. Let me see. Okay, you see I reported them here. So what can you conclude? You see that this value falls exactly inside the interval having as extremes the two critical values. So what can you do? What can you say? We can say, therefore, that at a tail probability of 5%, we do not reject H0 in favor of H1. That is, we do not reject the assumption that the statement made up by the broker is correct, because the broker stated that the expected monthly return of this portfolio is 1%, and the broker tells it because you want, for example, if you believe that 1% on a monthly basis is attractive, this is what is sponsored by the, I really believe that is really attractive on average. Depends also on the risk, but okay, we do not talk about finance, mathematical finance, but expected return, this means that on average you tend to get a return of 1%, is good on a monthly basis, guys. 1% on a month, on average 12% in a year. Oh, yes, it would be great. Okay, it would be great. And to consider, to verify if the statement made up by the broker who wants to sell you the portfolio, who wants you to invest in this portfolio, was possibly true, and our exam made up by considering 5 years of monthly returns seems to be consistent, provides empirical evidence in favor of H0, the statement made up by the broker. I also asked in particular to compute the p-value of the test. Okay, remember, since the test is bidirectional, remember that what you have to do, well, first of all, you have to consider the probability and other things. Look at this value. Is this value positive or negative? Negative. So you remember that, let me do a graph like this one. So suppose this is theta ops, which is negative, okay? Here you have 0, and here you have minus 1.96. Minus 1.96 is here, and then you have 1.96 here. Okay, so I repeat, here you have minus 196, here 1.96, and the observed value of the test is this one, okay, because it's negative. Remember, which is the p-value in this case? When you have a test which is bidirectional, is always 2 times what? Well, since the value is negative, we need to measure all this, the area on the left of this number, of this one. So we need to measure this area, okay, and since the test is bidirectional, we need to multiply this area by 2. So look what I wrote. The p-value is 2 times what? The probability that capital theta, that is a standard normal random variable, will assume a value smaller than the observed value of the statistic test, which is this one. Now take with me the tables, because this is useful again to reason on how to use the table. So we want to find, I repeat, the probability theta, I call it theta ops. Okay, theta ops. Suppose that theta ops is here. We want to find the probability on its left side, and then we want to multiply it by 2. Okay, but if you remember, if this number, oh no, okay, if this number, oh mamma mia, this number is negative, and here, however, you have only positive percentiles, so you cannot find directly this area. So I write here probability that theta is smaller than theta ops was 0. Minus 0.619. The minus 0. Well, I can write 62, okay, because we do not, okay, instead of 619, minus 0.62. But you cannot find, I repeat, a negative value here. However, you should remember, remember that the standard normal distribution is symmetric around 0. So the value such that this one, this value, I mean, the probability on the left of this value is this one. But if you consider the reciprocal of, not the reciprocal, sorry, the opposite of this number, suppose it's this one, the area on the left of theta ops is exactly equal to the area on the right of this theta. So what I'm saying, I'm simply saying that this value, I'm repeating again, is equal to this one, but is only changed by sign. So this value, theta ops, is minus 0.62. This value, theta, reported here, is 0.62. And 0.62 has an amount of probability on its right side equal to the amount of probability that theta ops has on its left side. So we can write that the probability, this is equal to what? To the probability that theta is greater than 0.62. Okay, you see this is an equality because this probability on the left is equal to this probability on the right. Now, guys, how can I continue here? I wrote, I'm sure I wrote everything also on the solution. Now, we want to compute the white area because the white area is equal to the green one, okay? And we want to measure the green one. So we can compute the white area. But remember that what? That the table are built to report the area on the left of theta, the green one, and not the white one. But we want to compute the white one, okay, because the white is equal to this one, okay? So how can we get the white? Well, it's very easy, because you know that 1, which is the total probability, minus the green area gives you the white. The white is this one. So I repeat, 1 minus, so the white is given by y minus the probability that theta will assume a value smaller or equal to 0.62. Now you have everything, because you have ma cosa è successo? Poi equal, oh, ma perché fa così? 1 minus, which is the probability that theta will assume a value smaller than 0.62. Now look here, go 6, 0, 6, 1, 62 is 0.7324. Okay, I can stop here because we have everything 7324 because I wrote everything, okay? I wrote everything. Here was only an explanation. So 1 minus this one, which is this green area, gives you the white one. But the white, which is this one, is equal to this one, which is exactly this. So it's a simple computation. Simple. We have, I mean, we have to do a very simple reasonment, okay, to get from here to here and from here to here in order to be able to use the table. And during the exam, I repeat, you can use the table. No, you have to take with you the table. You have to print them before the exam. Print the tables before the exam. You can use only the tables and a pocket calculator doing only simple operation. But I will repeat it, so we have a lot of times to repeat it. Now go back to the exercise and you will see if I wrote exactly what I told you. Yes, you see 2 times this probability, which is equal to 2 times this one, which is equal to 2 times 1 minus this probability. This is what I have just written on the tables, but I explained times 2, so you get this number. So what you get? You get a p-value equal to 53.52%. So it's super huge. So what does this mean? P-value bigger than the significance level tells you that at this significance level you accept the null. Exactly, and this is obviously is consistent with the previous result. But as I told you, the p-value is much more informative. Why? Because it allows you to understand the intensity of the empirical evidence, that is, the intensity of the evidence provided by data against or in favor of your hypothesis. In particular, you see that 53%, oh, and etc., is a very, very huge number. I told you that typically significance level is 1%, 5%, or 10%. But look at this number, 53%. This allows you to understand that there is a really strong empirical evidence in support of H0. So you accept, you do not reject H0, but the degree with which you do not reject H0 is really high. The H0 is really likely to be true, even if you cannot be sure, but it's really likely to be true, even if you cannot be sure at 100%. But you have that the p-value is really, really huge, so there is a really strong empirical evidence in support of H0 against H1. So it seems really that your broker is not lying. Okay, now question B, as always, turn on your microphone if you have question and you can stop me whenever you want, but turn on your microphone. Okay.
Professor?
Yes?
Sorry, but in this exercise, we also had like sigma equal to 2%, is that right?
Yes, but I told you to forget about it.
Okay, sorry. Okay.
If you want, guys, if this creates problem, you can cancel also the standard deviation if you want, because this also was another statement. One can also perform an hypothesis testing concerning, but I suggest to cancel it, okay, because I wrote the data, but then I never made use of it, okay?
Thank you.
So cancel if it creates confusion. Yes, no, thank you for the question. Yes, I told to concentrate only on this one, but please cancel so this does not create confusion in you for the future, okay? So cancel. This was a statement again of the broker. One can also test this one. Could also have tested this statement too. Yes, however, you're right. Thank you. So question B, guys. Again, guys, do like your friend. If you have questions, something is not clear for every reason, turn on your microphone. So question B, but stop me, okay? I read, but stop me if you have problems. Can we say at a significance level of 1% that the monthly expected return is smaller than declared by the broker? Here we tested the null against, but when you test an hypothesis, you test always the hypothesis against the alternative. For this reason, it is when you accept the null, it is better to say we do not reject the null in favor of the alternative. Why? Because you accept the null when you have that particular alternative. So it's better to say, but you do not accept absolutely the null assumption. So for this reason, statisticians and econometricians prefer to say every time we do not reject H0. Okay? We do not reject H0 against H1. Why? Because maybe, depending in some cases, I don't think this is the case due to the very huge p-value we had previously, but sometimes it can happen that if you have an alternative bidirectional, for example, you do not reject, and in the case you have an alternative unidirectional, you may reject it, or the contrary. It depends sometimes, but sometimes, okay. In this case, however, the p-value was so huge that this probably will make really no difference. However, we do it. Can we say at a significance level of 1% that the monthly return is smaller than declared by the broker? Compute the p-value of this test. Okay, what can you do? What can you do? Well, which is the alternative? The expected return is smaller, so the null assumption is exactly the same. Mu equal to 1%, the alternative is mu smaller than 1%. Observe also that the significance level is different now, it's 1%. So the statistic test, guys, as I told you in the last lecture, is not affected at all by the alternative assumption. So the statistic test to use is exactly the one we used previously, and therefore also the observed value is the same. When you change the alternative, the only thing that changes is represented by the critical or critical values. So the only thing we need to pay attention is represented by the new the new tail probability and the fact that the alternative is unidirectional on the left. So we need to find out the value of the theta that has on its left side an amount of probability of 1%, because alpha is 1%. Again, alpha is 1%, okay? So you see, I simply copied the previous observed value of the statistic test because this is not affected, I repeat, by the alternative. However, you see that I computed minus theta of 1%. If you take again the tables with me, what do you need to find? You need to find the value on the tables such that the amount of probability on its left side will be equal to 1%. Obviously, guys, this number will be a negative number, okay, because you want, I repeat, the value of theta such that this amount of probability, the one I'm touching, is equal to 1%. But remember, the value of theta such that its amount of probability on the left side is 1% is equal in absolute value, is equal to the value such that its amount of probability is 1%. So instead of searching this number, which is negative, and you cannot find it here, we search the value of theta such that the amount of probability on its right side is 1%, and therefore the amount of probability on its left side is 99%. Then we will change sign, so you get exactly the theta you wanted. So for this reason, guys, we want, I repeat, the value of theta such that this probability is 1%, but this is a negative value. But here in this table you cannot find negative percentiles directly. However, we can reason in this way. We find the value theta which is positive such that the amount of probability on its right side is 1%. And then we will change sign. But remember, the value of theta such that the amount of probability on its right side is 1% has a green area on its left equal to 99%. So again, you have to search 99%, which is, okay, guys, we find also these two values a lot of times, so we can consider 2.3. Here you have the 0, 1, 2. At the top of the table you have 3. So 2.3, 3. If you go above, you see 0.3 and this 3. So 3.33. No, 2.33. Let me go below. 2.33. So this is theta, okay? This is theta, but we want the value that has an amount of probability of 1% on its left side. So you have to change the sign of this one to get this number. So the critical value is minus 2.33. You see, minus 2.33. Remember, which is the rule of decision? The rule of decision is the following. You do not reject H0 if the observed value of the test falls on the right of this number. So, since in particular this number, the observed value, is greater than the critical value of the test, then we do not reject H0 at a tail probability level of 1%. So again, also against this alternative, the statement of the broker is correct. So is correct, I mean, we accept his statement is very likely to be true. You know, furthermore, I asked to compute the p-value. Which is the p-value of the test? Now, the test is unidirectional to the left. So what you need to do? Since the test is unidirectional to the left, the p-value is simply the probability that theta will assume a value smaller or equal to what? Or simply smaller? To the observed value of the test. So the p-value, in fact, look, I wrote probability that theta will assume a value smaller than this one. You can, I told you several times, with continuous variable, it's equivalent to use smaller or equal or simply smaller. Greater or equal is irrelevant for continuous random variable. Theta is a standard normal, is a continuous random variable. So we need to compute this probability, but again, take the table with me. But suppose that, suppose now that this is our observed value. Suppose that this is theta ops. So suppose that this is theta ops. So the p-value is probability that capital theta is smaller than theta ops. That is this area, okay? But again, theta ops is negative. How can you find this probability? Again, consider the opposite of theta ops, which is this one, which is a positive number. So the number, so the area on the left of this number, which is the opposite of this one, on the right of this number, okay, which is the opposite of this one, is this white area, which is equal exactly to this green one, okay? So instead of computing directly the green, we can compute the white because they are equal. So for this reason, if you go back, you see I wrote probability that this is smaller than this one is equal to what? I can add a step if you have troubles, but a step that we did similar to the one we did previously. The step is, if you need it, is equal to probability that theta is greater or equal to 0.619 or 6.2 or 62. 0.619, okay, 619, 619, okay, but you know that in order to compute this probability, how can you compute it? Remember that the table provides you the area only on the left, so you have to do the total area, which is 1 minus what? The probability that capital theta will assume a value smaller than small theta. The area on the left, exactly as we did in the previous question, guys. Exactly as we did in the previous question. In fact, you see that I wrote probability that theta is greater or equal than this one is equal to 1 minus this probability. Then we have already found out the probability that theta is smaller than 0.62 at previous point, guys, in the previous point. So I substituted and I got 26%, 76. So you see that again the p-value of the test is extremely huge. So we can say that there is a strong empirical evidence supporting H0 against H1. So again the statement of the broker is strongly supported by the data. Guys, if you have questions, ask me. Turn on the microphone. I saw something. Okay, how do you get minus 2.33? How do you get minus 2.33? So, to get minus 2.33, we are required, guys, to find the value of theta such that the amount of probability on